Welcome to section 2.7b, Solving Linear Inequalities. Our objective today is I can solve inequalities. So let's remember that with addition and subtraction, I could have the same two numbers, add numbers to both sides, and get the same thing. That's always good. With subtraction, it was the same way. I could have two numbers that were the same, and subtract the same thing from both sides, and I would find that they were both the same in the end. So likewise, we find that for inequalities, it's the same way. I can add things to both sides, and it will be the same. I can subtract the same thing from both sides, and it will also hold true. So let's try one together. Okay, I have x plus 5 is greater than 9. So I'm going to subtract 5 from each side, and I'll get x is greater than 4. Okay, I want to put this into interval notation or set builder's notation. So it's all the numbers greater than 4 going all the way to infinity. Remember that this one next to infinity is always a parenthesis because we can't ever include infinity. Infinity's not a number after all. So take a moment and pause the video and try this one out on your own. Now that you've had a chance to do that, let's take a look at this one together. So we want to solve the inequality and write the solution in interval notation. So I'm going to want to add 3/4 to both sides. I'll get p is greater than 1/6 plus 3/4. But I want to get a common denominator, so I'm going to multiply 1/6 times 4 over 4 and 3/4 times 6 over 6. That's going to give me p is greater than 4/24. That looked really bad. Let's redo that. 24 plus 18/24. Which, when we're all said and done, is going to be p is greater than 22 over 24. Or in set builder's notation, that looks like open parenthesis 22 over 24, comma, infinity. Okay, let's look at the next one. Solve the inequality, graph the solution on the number line, and write the solution in interval notation. Oh man, we got a lot of work to do, so let's get started. First thing we want to do, add 1/2 to both sides, just like we have been doing. We'll get n is less than or equal to 5 over 8 plus 1/2. Well, I need to get a common denominator since I'm adding them. So I'm going to multiply the 1/2 times 4 over 4 to get a common denominator. So I'll have n is greater than or equal to 5/8 plus 4/8. Which means that I'll have n is greater than or equal to 9/8. Okay, let's pop that into set builder's notation or interval notation really quick and say that, well, it's all the numbers less than or equal to 9/8. So, oh, that looks really terrible. So that's going to be all the numbers from negative infinity all the way up to 9/8 and including 9/8. So on our graph, that's going to look like a solid dot at 9/8 with the tail going towards infinity. Okay, let's look at the next one. Here's one for you to try. Go ahead and pause the video, and I'll see you in a second. Okay, now that you've had a chance to try it on your own, let's do it together. So I have n minus 1/2 is less than or equal to 7/8. So I'm going to add 1/2 to each side. These will cancel, and I'll get n is less than or equal to 7/8 plus 1/2. Well, just like in the last problem, I need to get a common denominator, so I'm going to multiply 1/2 by 4/4. And I'll get n is less than or equal to 7/8 plus 4/8. Then I'm going to add them together, and I'll get 11/8. So in set builder's notation, that's going to look like all the numbers from negative infinity all the way up to and including 11/8. And on my graph, that's going to be a dot slightly closer to 2, with our arrow pointing all the way down towards negative infinity. Okay, let's move on to something else. So let's recall that for multiplication across the equal signs, if I had the same two numbers and multiplied them by the same thing, I had the same thing. With division, it was the same way. I could have two numbers that were the same, divide them by the same number, and they would be equal when we're all said and done. Let's see if it's the same way for inequalities. Okay, I'm going to divide and multiply by a positive number. How about 5? So I'm going to divide both sides by 5, and we'll see if it holds true. Let's see, 10/5 is 2, and 15/5 is 3, and 2 is less than 3, so we're good to go. Booyah! Okay, let's take a look at multiplication. So I'm going to multiply both of them by 5. 5 times 10, that's 50. I know that one. And that's less, let's see if that's less than 5 times 15, which is 75. 50 is less than 75, so we're all good to go there. That looks good. Okay, let's see if it's the same for negative numbers. So I'm going to divide both sides by -5, and we'll see if this holds true. 10 divided by -5 is -2. 15 divided by -5 is -3. Am I supposed to believe that -2 is less than -3? Absolutely not. -2 is way bigger than -3. So that's not true. Let's see it. Let's see how it is for multiplication. I'm going to multiply both of them by -5. Okay, -5 times 10, well that's -50. -5 times 15, that's -75. And is -50 less than -75? No, it's not. So that's not true either, which leads me to one conclusion. How can we make it true? Well, how about I flip the sign? If I flip the sign, then all of a sudden it will become true. So, let's remember when we divide or multiply by an inequality by a positive number, the inequality stays the same. And if we multiply or divide an inequality by a negative number, the inequality reverses. It reverses. Okay? Let's try one together. Let's solve the inequality, graph the equation on the number line, and write the solution in interval notation. Okay? So, we're going to divide both sides by -9 to get the y by itself. I'll get y, and since I'm dividing by a negative number, I'm going to flip the sign. Y is greater than -5, because 9 times 5 is 45. So, now it's time to put it into interval notation. So to put it into interval notation, y is greater than negative 5. So negative 5 is on the low end, and there's not equal to, so it can't be negative 5. And this is going to go all the way up to positive infinity. Okay, so let's find that on my number line. Here's negative 5. I'm going to put an open circle since it doesn't include it, and an arrow pointing towards positive infinity. Right? So why don't you try one? Okay, so go ahead, pause the video, and try this one out on your own. And I'll see you in a little bit. Okay, now that you've tried it for yourself, let's do it together. Negative 70r is less than or equal to negative 70. So I'm going to divide both sides by negative 7 to get rid of that negative 7. So now I have r, and I'm going to flip the sign because I'm dividing by a negative. I'm going to flip the sign, and it's going to be r is greater than or equal to negative 70 divided by 7. Those negatives are going to cancel out. I'll get positive 10. Okay, so let's build our set builder notation.